Yo, what up? It's your boy Russell coming at you live from the 218. That's right, room 218. Today we're here to talk about trigonometric applications. Just figured I'd switch my intro up a little bit. Trigonometric ratios are used to solve right triangles when the measure of an angle and the length of a side are given, or when the lengths of two sides are given. The underlying idea is that the definition of each trigonometric ratio involves three quantities. So we have the measure of an angle, and then there has to be two sides. Think about, as we're talking about these trigonometric ratios, so katoa, sine of an angle, is the opposite over hypotenuse. Cosine of an angle is the adjacent over the hypotenuse. So that's the angle and two sides. And then tangent is opposite over adjacent. Tangent of an angle equals the opposite over the adjacent side. So every one of these involves one angle and two sides of the triangle. So how do we find the side of a triangle? Well, if I look at this, I am given the side 8, an angle 65, and an x for the other side. And I don't know this other side. So that's what I have to find. If I'm trying to find the side of an angle, I first need to figure out, or the side of a triangle, I first need to find out which angle it is that we're looking at. And it starts here. It's angle 65 is the one that we're given. And from there, I need to figure out how these two sides relate to this angle. In other words, if this is my angle, is this side adjacent or opposite of the angle? It would be adjacent. What would this side be? The hypotenuse. So I know that I have adjacent and hypotenuse, and now I need to think of which trig ratio involves those two. It's got to be the cosine. So I have the cosine of 65 is equal to adjacent, or x, over the hypotenuse 8. Now I just have to solve for x, which means I'm going to multiply both sides by 8. And I have x equals 8 times the cosine of 65. Now that's a beautiful answer, but does it really tell me anything about my side length? Like if I was asking you how long a board should be, if you told me 8 cosine of 65, that's not telling me very much. So I now have to get out my calculator. Make sure you go into mode and make sure it is in degree mode because it's 65 degrees, not radians, which you haven't learned about yet, but we will get into shortly. So now I just put it in the calculator. 8, I don't even have to put times. Cosine 65. Enter. It gives me approximately 3.38. So that's my side length. And that's really it for that one. I just got so nervous it wasn't recording. That's all we have to do. It'd be helpful if we weren't drawing stuff, but that's better. That takes us to our next type of question. How do I find the measure of an angle? So I just figured out how to find the measure of a side. How do I find the measure of an angle? Well, this is my angle. I have all three sides given to me, which means I have all three sides necessary to find any of the trig ratios. It could be sine, tangent, or cosine. So really for this one, it's your pick, however you want to do it. Let's start with the sine. If I do sine of theta equals, and then it's opposite over hypotenuse. So that's 3 over 5. Now, something we haven't done yet is look at the angles. So the way that you used to have to do it was you would look at a table and find which angle would give you 3/5. That was kind of a pain, but luckily now we have the technology necessary to figure it out. Now, one mistake most people do is, or some people do, is they think that like this is sine times theta and that they can just divide. That's not possible. So you don't want to do that. What you will notice is that whenever you're looking at the calculator, is that in your calculator, above each key, you'll see in blue, it says sine to the -1. That means we're taking the sine inverse, which will cancel the sine out on this side. So if I do the sine inverse of this, it's going to cancel your sines out, which then means I take the sine inverse of that side. So all I would be left with on the left is theta, and then sine inverse of 3/5. Make sure that 3/5 is in parentheses. Otherwise, it may think that you're doing the sine inverse of 3 and then dividing by 5. So we push second, sine, 3 over 5, close your parentheses out. It gives us 36.87. That's degrees. I mentioned that we could have used any of the angle or any of the trig ratios. Say, for instance, I had used cosine. Remember, cosine is adjacent over hypotenuse, so it would be cosine theta. This side is the adjacent side, so that would be 4 over 5. Take the cosine inverse of both sides. That would give me theta equals cos inverse of 4/5. If we put that in our calculator, we should come up with the same exact number. So that's a good way of checking to see if you did it correctly if you're given all three. Cosine inverse of 4/5. See, it gives you the same exact thing. If we did the tangent, we could do opposite over adjacent. Opposite over adjacent. And you guessed it right, it would just be tan inverse of the opposite, 3 over 4. You see, they all give us the same thing. For these ones, you don't have to use all three. It's just an option. It's a good way to check if you have done it correctly. You think a number is coming up weird. Remember, you should never get a number bigger than 90. There's only 180 degrees in a triangle. So if I'm starting with a right angle already, then I can't get 90 here because that would be 180 already and wouldn't leave any for this side. Moving on, solving a right triangle. Make this a little bigger. So I have theta up at the top, then 17, A and B. So I have a little bit more to solve on this one. When I look at this one about how to solve it, I just referenced the fact that we know there's 180 degrees in a triangle. And so if I needed to find my theta, I could do theta equals 180 minus 90 minus 75. And that would give me 15 degrees. Know that this angle is a 90, this is a 75. 180 minus 75 minus 90 gives us the last angle, 15 degrees. So now I need to find my two different side lengths, A and B. If I start at this 75-degree angle, which would be my hypotenuse? It's got to be the one that's opposite of the 90. So that's the hypotenuse. This would be opposite of 75. This would be adjacent to 75. So I can use my sine function to find A. Sine of 75 equals opposite, which is A, over 17. Multiply both sides by 17. I get A equals 17 times the sine of 75. Now all I have to do is put that in the calculator. (17 sine 75), and I get that A is 16.42. Now I need to find B. So for B, this is adjacent, the hypotenuse, so I can do cosine of 75 equals B over 17. Multiply both sides by 17. I get B equals 17 times the cosine of 75. Put that in the calculator, if I can grab the calculator. Uh-oh. That's nice. 1 second. Let's get the calculator back up. There we go. Because I messed up on my calculator, I'm going to have to put that back in degree mode. Now I do 17 cosine 75. That gives me approximately 4.4. So that's it for solving right triangles. We have other options that I'm going to show you in the video tomorrow for how to solve the same exact problem using different trig ratios and things of that nature. All right, peace out from Russell, 218.